Welcome to Physics 100 Introductory Physics. This course studies the impact of physics on everyday life. Topics include motion, forces, gravity, energy, power, and heat. Conceptual understanding is emphasized over mathematical manipulation. However, the language of physics is mathematics, so you will be required to use basic algebra to solve many of the problems. We begin with Chapter 0, an introduction to physics. The goal of this chapter is to introduce you to the methods of science and to describe the process of rational thinking. See if you can answer this question. What is science? Science is a branch of knowledge or study dealing with a body of facts or truths systematically arranged and showing the operation of general laws. Science is systematic knowledge of the physical or material world gained through observation and experimentation. Physics is the science to understand the rules of the physical world, motion, forces, heat, light, etc. Find physics in many everyday ordinary things. Aerodynamics is a branch of physics concerning with the studying the motion of air, particularly when it interacts with a solid object such as an airplane wing. Physics describes the methods of power generation, chemical and nuclear physics. Power transmission is a branch of electricity and magnetism. Optics is a branch of physics which involves the behavior and properties of light, including its interactions with matter and the construction of instruments that use or detect it. Electromagnetic radiation is the radiant energy released by certain electromagnetic processes and give rise to an electromagnetic spectrum, what we typically call the rainbow of colors. But the rainbow extends to the ultraviolet, X-rays, gamma rays, infrared, radio, and microwaves. The motion of air and water droplets give rise to a separation of charges, producing static discharges, sometimes felt as a shock when you touch the doorknob after walking across a carpet, are often seen as lightning discharges. Stars shine by the fusion processes found in the center of stars. Automobiles show a variety of physical processes from aerodynamics, power generation, motion, forces, and heat. The interaction of particles from the sun and the Earth's magnetic field give rise to the aurora, often called the northern lights. We will look at many of these processes as we go through this course. The motto for the Science Channel is "Question Everything." It is a good motto, but as many people ask questions, they do not realize when they get the right or wrong answer. They lack the cognitive skills to evaluate what they have learned. Hopefully, you will add skills to your toolkit and be more able to recognize the right and, more importantly, the wrong answer. Does the answer make sense? Is what we want to ask. But there is a problem. Many people try to use common sense when responding to the question. Common sense works most of the time, but it doesn't always work. There are many parts of physics that are outside normal experiences, so we can be fooled if we only rely on common sense. We expect the world to act or react in certain ways. Sometimes it doesn't react the way we expect. What the scientist does is to reevaluate the way he or she looks at the world. Nobel Prize-winning physicist Richard Feynman once said, "Science is a way of trying not to fool yourselves." We are the easiest to fool. Many people have preconceived notions, opinions, formed beforehand without adequate evidence. Once these notions are ingrained, it is difficult to change a person's mind. This leads to pseudoscientific ways of thinking. Now answer, what is pseudoscience? Pseudoscience is a claim, belief, or practice which is presented as scientific, but does not adhere to a valid scientific method, lacks supporting evidence, or plausibility, cannot be reliably tested, or otherwise lacks scientific status. We can try a few simple tests. First, understand that physics is based on observations. The question is, how good of an observer are you? Look at these two images. Can you see any differences? On the left, upside down, and the image on the right, right side up. When the second right side up image was in an unfamiliar context, upside down, our brains filled in the missing pieces. Now right side up, the differences have become more obvious. When the image on the right is upside down, it is outside of our normal experience. It has to make sense to us, so we see what we expect to see. This is known as confirmation bias. Confirmation bias is a tendency to search for, interpret, favor, and recall information in a way that confirms one's beliefs or hypotheses, while giving disproportionately less consideration to alternative possibilities. It is a type of cognitive bias. Second test. Read the sign out loud. Did you notice the consecutive thes? Many people don't. They subconsciously ignore the extraneous information and skip the second the. This makes more sense. It is confirmation bias. Now let's see how well your memory works. The task: draw a bicycle. I will give you a little bit of time to do this. Here are some common errors. The top two drawings both show pedal and chain errors for a man who said he cycled at least once a month, on the left, and a woman who said she never cycled, on the right. The bottom left drawing shows both frame and chain errors for a woman who said she cycled most days. The bottom right drawing shows the very rare triple combination of frame, pedal, and chain errors for a man who said he rarely cycled. This shows that memory cannot always be trusted. Studies have found that memories are inherently biased and can contain many errors. Science looks for objective measures, not subjective. This leads to a reliance on instrumentation. For the non-scientists, this becomes an issue because they are these big, complex machines that they do not know how they work and become untrusted. And heart are just two examples of complex instruments that are misunderstood by the general public and are subject to many conspiracy theories. They simply collect data. So what is data? Data is just information. It can be eyewitness accounts, but more often in science, it is mechanically recorded measurements of some quantity: pressure, force, brightness, mass, etc. So what do scientists do with all the data collected? Scientists look for correlations because correlations could indicate some underlying mechanism or reason for occurrence. Correlation is a mutual relation of two or more things, parts, etc. For example, from correlations of the rock sequences exposed at different localities, geologists can reconstruct a geologic history over 1 billion years long. Number of Republicans in the Senate affect the sunspot number, or do the sunspots affect the number of Republican senators? In this case, neither. They are mere coincidences. Another strong correlation is the number of people who died by becoming entangled in their bedsheets every year, around 700 in 2009, and the per capita consumption of cheese. These events are correlated. Here are the number of people killed by venomous spiders correlated with the letters in the winning word of the Scripps National Spelling Bee. These also are correlated. However, correlation does not imply causation. It is one thing to look for correlations, but you have to go on a step further and look for the causes. We have to realize that sometimes coincidences happen and with no underlying cause. Science looks for causes of correlations, not just correlations. In middle school or high school, most of you learn the scientific method. You make an observation and formulate a question. From there, formulate a hypothesis. Then you predict consequences of the hypothesis. You test the predictions. Then you analyze the test, draw conclusions, and make modifications to the hypothesis if necessary. The scientific method is the method of looking for causes. Serendipity is discovery by accident. Alexander Fleming discovered penicillin in 1928 when he noticed that Staphylococcus died when the petri dish became contaminated with a certain type of mold. Trial and error does not strictly adhere to the scientific method. It is a random application of different things until something works. Contrary to opinion, Thomas Edison did not invent the light bulb. However, he improved the design and discovered a long-lasting filament, carbonized Japanese bamboo. Edison just kept trying many different materials until he hit upon one that worked. We do not ignore serendipity and trial and error in science. Think about the definition of theory. What do you think theory means? Is it a hypothesis assumed true for the sake of argument, an unproved assumption, a conjecture, or a guess? If you are like most people, you think of a theory as a hypothesis assumed true for the sake of argument, or an unproven assumption, a conjecture, or a guess. Actually, none of these are correct. In science, theory has a very different meaning. In science, a theory is a well-substantiated explanation of some aspect of the natural world that can incorporate facts, laws, inferences, and tested hypotheses. In science, theories do not turn into facts through the accumulation of evidence. Rather, theories are the endpoints of science. They are understandings that develop from extensive observation, experimentation, and creative reflection. They incorporate a large body of scientific facts, laws, tested hypotheses, and logical inferences. The theory of gravity and the theory of evolution are not guesses. They are well-substantiated understandings of the physical world. We use this definition to distinguish between science and pseudoscience. Always follow the scientific method. even though they may present information as if they did. Pseudoscience tends to be selective of prediction failures. Pseudoscience counts all the successes, but explains away or ignores all the failures. Pseudoscience might say that something cannot be measured. You just have to believe. When you hear descriptions of unmeasurable energy, magic ghosts. You are listening to pseudoscience. You don't want to be this guy. You want to form opinions based on logic, not ignorance. Science and pseudoscience as science has the willingness to change with new evidence, while pseudoscience uses fixed ideas, often from hundreds of thousands of years ago, and the ideas have not changed with new information or technological advances. Scientific studies undergo a ruthless peer review, exposing any shortcomings or fallacies in the argument. Pseudoscience often ignores the peer review process, or if it has one, it is more of bestowing accolades rather than looking for problems. Science takes into account all new discoveries, while pseudoscience ignores the unfavorable evidence. Science invites criticism, but pseudoscience sees criticism as a conspiracy and attempt to suppress the truth from the public. In science, the method of obtaining results is carefully spelled out so others can repeat the process. In pseudoscience, many things happen only once and cannot be repeated, but are still accepted to be true. Surprisingly, science limits its claims of usefulness. Pseudoscience, on the other hand, says its methods or processes can be used in a multitude of various applications. Cures the common cold, makes your teeth whiter, gets better gas mileage, and makes your hair grow thicker. Science always tries to improve the accuracy and precision of measurements, while pseudoscience tends to use ballpark measurements or relies on anecdotal evidence. Popper, between 1902 and 1994, was a philosopher who wrote about the philosophy of science. His ideas are a large influence on the modern description on how science is done. Popper introduced the concept of falsifiability into science and addressed the problem of demarcation. Scientific statement is one that could possibly be proven wrong. A falsifiable statement is not a statement that is wrong. However, a falsifiable statement always remains tentative and open to the possibility that it is wrong. Of non-falsifiable statements. An alien spaceship crashed in Roswell, New Mexico. A giant white gorilla lives in the Himalayan mountains. Loch Ness contains a giant reptile. How do you show a spacecraft didn't crash in Roswell? You show them no spaceship parts. In each case, if the statement happens to be wrong, all you will ever find is an absence of evidence. No spaceship, no gorilla tracks in the Himalayas, nothing but small fish in the loch. These statements cannot be falsified by the accumulation of evidence and are therefore not scientific. These are examples of falsifiable statements. No alien spaceships have ever landed in Roswell, New Mexico. The statement is falsified if we find a piece of an alien spacecraft. There are no giant white gorillas living in the Himalayan mountains. The statement is falsified with evidence of a white gorilla. This critter just pulled from Loch Ness is a fish. The statement is falsified if the creature does not have the traits of a fish. So how to tell the difference between a falsifiable and a non-falsifiable statement? In most cases, a falsifiable statement just needs one observation to disprove it. If you find a piece of an alien spacecraft, you have disproved the statement that no alien spacecraft crashed in Roswell. A statement that is not falsifiable usually needs some sort of exhaustive search of all possibilities to disprove it. To prove no Loch Ness monster, you have to drain the loch, explore every possible inlet, outlet, or cave. You also have to account for invisibility and teletransportation. It realistically cannot be done. A word about Roswell. Keep in mind that the city of Roswell derives income from tourist dollars, and if the myth about a UFO crash disappears, then so would the tourists and so would the income from tourists. It is in their best interest to keep the myth alive. There are fish in Lake Nyack. Is this a falsifiable statement? No. To falsify it and prove that there are no fish, you would need an exhaustive search of all the places that they might be hiding, and you cannot actually do that. Right? What about all of the fish in Lake Nyack are green? Is that a falsifiable statement? Yes. Finding just one red or brown or pink fish would falsify the statement. All of the fish in Lake Nyack are beautiful. Is that a falsifiable statement? No, you cannot falsify a matter of opinion. Hierarchy of scientific knowledge. We begin with speculation, a vaguely formed idea, usually based upon limited observational material. Then we have a hypothesis, a tentative explanation of a phenomenon or group of observations in terms of causal mechanisms. Scientific hypotheses are often expressed as mathematical relations between observable quantities. A valid scientific hypothesis must have predictive value, which renders it falsifiable. Next, we have theory. A theory is basically a hypothesis which not only succeeds in explaining some phenomena, but all of whose predictions have been adequately confirmed, when possible, by means of additional observations or experiments. A theory is a successful working hypothesis with remaining predictive power. A theory is not a guess. Finally, we have a law. A law is a scientific theory with broad predictive power, usefulness, and an extensive history of successful testing might be elevated to the status of a scientific law, particularly if it forms the basis for explaining a wide range of phenomena. Confirmation bias is a tendency to search for, interpret, favor, and recall information in a way that confirms one's pre-existing beliefs or hypotheses, while giving disproportionately less consideration to alternative possibilities. It is a type of cognitive bias. According to Karl Popper, confirmation should count only if they are the result of risky predictions. That is to say, if unenlightened by the theory in question, we should have expected an event which was incompatible with the theory, an event which would have refuted the theory. Confirming evidence should not count except when it is the result of a genuine test of the theory, and this means that it can be presented as a serious but unsuccessful attempt to falsify the theory. I now speak in such cases of corroborating evidence. An ad hoc explanation means the addition of extraneous hypothesis to a theory to save it from being falsified. An ad hoc hypothesis compensates for anomalies not anticipated by the theory in its unmodified form. A paranormal investigator investigates psychic waves under scientific controlled conditions. Upon finding that the experiment did not give positive results, They blame the negative brainwaves given out by others. Astrology is a system of divination based on the premise that there is a relationship between astronomical phenomena and events in the human world. Astrology is the study of correlations of celestial events with behavior on Earth, particularly correlations which cannot be explained by gravitation, magnetism, or other forces that are well established in physics or other sciences. Questions for astrology are: how does it work? And is it science or pseudoscience? We will investigate this question in a lab exercise. For Chapter 0 are to read Chapter 0 in the textbook. Chapter 0 homework is due January 26th. The review questions are on pages 8 and 9, problems 1, 5, and 8. On Blackboard, you will also find 2 video links. These are Counting Basketball Passes and Here Be Dragons. Watch these 2 videos.